In this lesson, I'm going to go over some of the properties of limits that basically allow you to take more complicated expressions and break them down into smaller limit problems that you can work out individually and then sort of put them all back together at the end. There are going to be 4 properties that I'm going to show you. These aren't official names, but they're basically the constant multiple property, so how you deal with a function that has a constant multiplied to it. The addition property, where you have 2 expressions that are added or subtracted to one another. There's a multiplication property, where you have 2 expressions that are multiplied to one another, and the division or the quotient property, where you have 2 expressions that are either divided or that are sort of set up as a rational expression. So I'll sort of go through each of those and then we'll take a look at an example. So the constant multiple property, and just for your own notes, this statement up here is gonna stay the same for all the problems I'm about to look at. So what it's saying is, given that you know that the limit of f of x is L and the limit of g of x is m. So like as you approach c, f is getting closer to capital L, g is getting closer to capital M. So I mean, these would be numbers. This might be 5, this might be 7, this could be 0, this could be -1. What's important is that both of these exist. Right? So these rules don't really apply if one of those limits doesn't exist. Okay? So the constant multiple property says if they're asking you to do the limit of some function times a constant, and you know what that limit is, like we know it's L, you can just multiply your constant times L. It's almost like what it's saying is that you can take, in fact another way of saying this is that you can take that constant and pull it out. You can say, oh, this would just be a times the limit as x approaches c of f of x. Right? And because we know that that thing is L, we get that this is a times L. The next property is the addition property. So remember I said that these given statements up here were the same for all of them, so you don't need to write them separately for each one. I just wanted you to have it as a reference. Again, as we approach C, F is approaching L, and G is approaching M, the addition property says that if you're adding 2 functions together inside of a limit, you're effectively allowed to do the limit as x approaches c of f of x plus the limit as x approaches c of g of x. Right? So because we knew that this one was L and this one was M, this limit is just L plus M. The next one is the multiplication property. Very, very similar. If you have 2 functions being multiplied together, you can simply take their individual limits and multiply the limits together. Right? And I've been writing it for the other one, so I might as well write it for these. It sort of means you can do the limit as x approaches c of f of x times the limit as x approaches c of g of x. And in our case, like in this little problem, sure, that means I know this one is L and I know this one is M, but it might also be that you had some expression that was kind of crazy and you wanted to break it into 2 pieces so it was easier for you to deal with. I think this one requires a little bit less explanation because it's really similar. If you have 2 functions being divided, you're welcome to take their limits individually and just write them as a fraction. The one kind of exception to that is, if m is 0, you can't really use this property because L over m would be undefined, right? So the example that I have is this one. Given that the limit as x approaches 2 of f of x is 5, and the limit as x approaches 2 of g of x is -3, I want us to find this limit. If you're feeling up to it, pause the video, think about how you could break up this limit into different pieces, and then solve it. So I hope you took a chance to do that. What I'm first going to do is I'm going to sort of use the addition property, right? I'm going to say, well, this is something plus something else. So I could write this as the limit as x approaches 2 of x squared f of x plus the limit as x approaches 2 of g of x. Right? And at this point we recognize, like, I know what that is. This thing is simply -3. Right? So now I've simplified my expression a little bit. Now if you didn't pause the video before, pause it now and think about how would you break this up? How could we work better with this? Well, again, we could sort of write, there's 2 things multiplied. We could write the limit as x approaches 2 of x squared plus the limit as x approaches 2 of f of x, right? And in the case of this one, again, we know what that is. This is 5. So I've got 5 plus the negative 3 that we got before. The last thing I have to deal with is how am I supposed to do the limit as x approaches 2 of x squared? Well, remember how we deal with all limits. We try just plugging in the number. What happens if I just attempt to evaluate this for 2? Well, it works. When I plug that in, I get 4. And so when I add all these up, I end up with 6. And so 6 is what this limit would be. I hope that made sense. We'll get a chance to practice some of those in class tomorrow. And you're going to see that this is also incredibly useful for the next lesson that we go into when we start doing trig limits. So I'll see you there.